So good afternoon. B2 and B3 batch is there. So under the subject of heat and mass transfer, today we are going to conduct one experiment. The title is determination of thermal conductivity of insulating powder. And in this, the insulating powder which we are going to use, it is a asbestos powder. Okay. So let's check out what is the content of this practical. So starting, obviously there is a basic theory. So theory related to thermal conductivity. So thermal conductivity is the property of material which is used to segregate the materials in a conductor and insulator. Remember, now we are talking about heat transfer subjects. So conductivity and dependent conductivity, the material is segregated on either it is a thermal conductor, that is heat conductor, or thermal insulator. Okay. So thermal conductor, just like a metals, various metals, very well known, it is a thermal conductive conductors, and remaining which having a very less thermal conductivity, we use those material as a thermal insulator, just like a rubber, wood, plastic, asbestos. So all these material we use as a thermal insulator because it having a lowest value of thermal conductivity, due to which heat transfer rate is minimized. Okay, so rate of heat transfer is minimized, so temperature gradient or the temperature reached to the second side is lesser, so we can use as a insulator, thermal insulator. Now these are some standard values of thermal conductivity of various material, but remember all these values are identified at standard experimental conditions on standard experiment setup. Definitely our practical equipment is not that much accurate, so we never get exact value. If we get exact value, then that is a just a coincidence, because these instruments, whatever our practical labs are there, it is not highly calibrated, or even though the working conditions are not as per the standard required working condition. So definitely there will be a value difference, but it should nearby to these standard values. Okay, we will try to do that. Next, this is our experimental setup, exact experimental setup schematic. So in our experimental setup, there is two spheres, inner hollow sphere and second outer hollow sphere. And in these two spheres, the annular space is packed by asbestos powder. Remember, it is in a granular form, powder form. And one heater is provided inside the inner sphere, and it is connected with a dimmer stat. With the help of dimmer stat, we can vary the voltage and corresponding current. So we can adjust this heater to provide a one particular amount of heat. This heat will reach to inner surface of this sphere, and to measure the temperature of inner sphere, there are randomly 4 thermocouples are mounted, T1, T2, T3, T4. When we are interested to find out the temperature of inner sphere, so we have to take an average of this T1, T2, T3, T4. So that average temperature we assume as a temperature of inner sphere. Now the heat is transferred to inner sphere get heated, and this heat is now try to transfer through this asbestos powder bed. No doubt it become a hollow spherical shape. So heat is transferred through this asbestos insulating powder and try to reach to outer sphere. As the insulating powder is there, so it is not allow readily to transfer the heat, but after 30 or 40 minutes heat reach to outer sphere. So during conducting our experiment, we have to wait at least 30 minutes or 20 minutes, so that never start note down your readings as you switch on your equipment. Why? Because when you switch on your equipment, your inner sphere might be possible it gain a heat, but it is not possible that heat is transferred from inner sphere to outer sphere. So it takes some time. So minimum 30 minutes wait. After 30 minutes, start note down first reading. Okay. In reading, what we have to note down? T1, T2, T3, T4. That is inner sphere temperatures. Then T5, T6, T7, T8, T9, T10, outer sphere temperature. How outer sphere get heated? Due to the heat transfer from inner sphere to outer sphere through this asbestos powder bed. So we have to note down repeated 3 or 4 readings, and then we will make an average. But for most accurate, we have to consider the last reading, because till last reading we are close to steady state condition. We are not expecting within 2 hours we reach to the steady state condition of this equipment, but we are close to steady state condition. So last most reading will be the most accurate. Next, safety precautions. So always remember, any equipment which having a dimmer stat. So before start your equipment, check whether your dimmer stat is at 0 condition or not. If it is not, then make it 0. And then after, start it. And setting particular voltage, don't rotate that dimmer stat in a very high speed. Rotate it very gradually, slowly, and set a particular voltage. Any switch, any operator, knobs, operate it in a very gentle manner. Okay, and remember, never exceed 250 volt for any equipment. Okay. Now the procedure. As I already said, the procedure, we have to start our panel, then increase input voltage with the help of dimmer stat, set any particular value, suppose 40 volt or 60 volt or 70 volt, corresponding current will be there. So we can adjust our input voltage by varying a dimmer stat position. Then after, don't note down readings, just wait for 30 minutes so that at least it heat is transfer from inner sphere to outer sphere. Definitely in 30 minutes it is not going to reach a steady state condition, but your first reading should be after 30 minutes when you set a particular voltage. Okay. Then after 30 minutes, in an interval of 10 or 15 minutes, you have to note down 3 or 5 readings. So this is our standard procedure. Then observations. Observations, what are given? So inner sphere radius is given, that is 50 mm. Inner sphere is material is a copper. Outer sphere also made up of copper, and its radius is 100 mm. Insulating powder, as I said, it is asbestos powder. Now input voltage, whatever be the input voltage we are going to set, we have to note down here, and corresponding current we have to note down here. We can vary our voltage, and accordingly current will be displayed on current ammeter. Now this is our observations table. As I said, we have to only note down the temperatures. So in this temperature T1, T2, T3, T4, all these 4 temperatures are mounted, thermocouples are mounted on inner sphere. And T5 to T10, these 6 thermocouple are mounted on outer sphere. the dial or that indicator going to show the reading of temperature, it is in degree centigrade. So this is a 10 minutes, but 10 minutes after your waiting period, that means after 30 minutes. So it is not 10 minutes after switch on your equipment, 10 minutes after your waiting periods. So likewise, we have to note down 3 to 4 readings. Many times it is observed that we take a mean of all these, average of all these readings, or the last reading which is most closely to steady state condition, we can use that readings. Next, the sample calculation. So sample calculations, we have to calculate first heat supplied. How to calculate heat supply? So we know that we are setting some particular amount of voltage and corresponding current is there. So multiply voltage and current, so that much amount of heat we are actually supplying. After steady state condition, whatever be the supply of heat, it is going to transfer. Now the mean temperatures. So average temperature of inner sphere. So inner sphere having 4 thermocouples, so make an average of these 4. So it is Ti, inner sphere temperature, Ti. Outer sphere temperature, so make an average of outer sphere thermocouple reading. So it gives To, temperature of outer sphere. So we have two values, inner sphere average temperature, outer sphere average temperature. Next, thermal conductivity. Now it is a sphere, hollow sphere. The cavity insulating powder making a hollow sphere cavity. So heat transfer rate formula is 4 pi k Ri Ro multiplied by Ti minus To divided by Ro outer sphere radius minus inner sphere radius. In actual, if you are going to see the exact formula, then it will be Q is equal to delta T, Ti minus To divided by Ro minus Ri divided all these quantity. But after rearrangement, it come in a numerator value. But we are interested in finding the value of this K, thermal conductivity. So we are shifting all other parameters. So K is equals to Q, which already known by multiplying voltage and current, Ro minus Ri. So it is given. We have to just change the unit. If it is given in mm or centimeter, we have to convert into meter. 4 pi Ri multiplied by Ro divided by Ti, average temperature of inner sphere minus average temperature of outer sphere. So whatever be the value is there, it is the thermal conductivity of that asbestos powder. Thereafter, in our write-up, we have to write down a result. So after calculation and all this exercise, the result will be the thermal conductivity of given, that is the asbestos powder, insulating powder is. Whatever be your final answer, we have to know right here what is the value of that thermal conductivity. And the conclusions. So after conducting this experiment, what is the conclusion? From the experimental data, it is concluded that by knowing the temperature difference, heat input and dimension of sphere, the thermal conductivity of any material packed in a spherical annular space can be calculated. This is our conclusion. Imagine, suppose I remove that asbestos powder and I put some sand. So after conducting experiment, we can identify the thermal conductivity of sand. If I remove that sand, I put chalk dust, then after conducting experiment, I am able to identify the thermal conductivity of chalk dust. So conclusion is not based on a result. It is what we learn. So we learn that if we know the temperatures, if we know the heat transfer, heat input, if we know the shape, geometry in which that powder is packed. So if all these inputs we know, then we are able to find out the thermal conductivity of any material. That is our conclusion. Okay. Now I will switch over to my mobile and we will check out exact experimental setup. Okay, now I am audible there. So we will see the exact experimental setup. Just a moment. Let me stop presentation from my desktop. Okay. So I think this equipment is visible to all.
Yes, sir.
This is one spherical ball, correct? Yellow color ball is there. So this externally it is appear like a spherical ball, but inside there is one inner sphere made up of copper. Outside there is a again outer sphere made up of copper. After that outer sphere is covered with some insulating material, and this is outer metallic sheet metal covering. This is not a outer sphere. Okay, remember outer sphere is inside this. After that, there is some insulating material, and this is simply a casing. There is one port. From this port, you can open it and you can replace the different material inside this cavity. Whatever with the thermocouple attached to inner sphere as well as outer sphere, it is connected to this display, temperature display, knob kind of display. So we have to shift knob. If it is at T1, so it is going to show the thermocouple T1 temperature. T2, likewise. Whenever you are going to start equipment, always check whether it is at zero or not. If it is not, then set to zero condition. Then make it on. Now slowly, gradually rotate this dimmer stat and set the value of voltage. Voltmeter is here and corresponding current will be displayed here. So set the voltage. Suppose I am fixing the voltage value 60. So 60 volt supplied and corresponding current is 221. Remember, as your coil and other thermocouples get heated, so due to heat, this value may little bit vary. Okay, this becomes 60. It may change to 61. This is 221. It may change to 222 or 223. Likewise, after heating, there are slight changes. Okay. Now, this is basic setting. After that, we have to wait for 30 minutes waiting period. But we don't have that much time. So imagine after 30 minutes, we are going to note down the readings. So during note down, after 30 minutes, T1, 37, T2, 44. As thermocouple are randomly mounted. So some thermocouple showing different values. T3, 36, T4, 40, 39, 38. We have to wait for a steady reading. If it is not, then just go back and come to again T4, 42. Now outer sphere, T5, T6. You can observe that T5, T6 onward temperature are lesser because heat is not reaching that extent. T7, T8, T9, T10. T11, there is no thermocouple, so it is just like a dash. T12, there is no thermocouple, so it is again dash. So this is our first set. After this, we have to again wait for more 10 minutes. Then second reading, we will note down from T1 to T10 again. So likewise, we have to note down 3 to 4 readings at least. So let me stop here presenting. We will go back to my desktop again. Okay. So is there any question, any doubt how to conduct? If there is any doubt, just ask me right now.
No, sir.
Okay.
So when should we submit the write-ups?
That is the last end portion. We will discuss it. Regarding right now, till now, whatever be the practical content was there explained. Is there any difficulty, any doubt? Then please ask right now. Regarding submission, I will discuss later on. Okay. So procedure, you come to know how to conduct that experiment now. So whatever be the PPT content is there, it is the actual content of your write-up. So after conclusion, it is not possible online to conduct your experiment throughout for 2 hours because it is a heat related issue. So we have to wait for more time to get a steady state. So it is not possible to conduct all the readings in practical hours. So a day before, on Saturday, I already conduct this experiment and note down the corresponding readings. So these are the corresponding readings which you have to use to write up your experimental practical experiment. Okay. So this is time frame 20, 30, 40, 50, 60. Inner sphere temperature T1, T2, T3, T4. These are the readings which I observe. Then outer sphere temperature T5, T6, T7, T8, T9. These are the readings. Then at last I make a mean of all these. So average. And on the basis of this average reading, you have to calculate what is the thermal conductivity of that insulating powder. Okay. For my experiment, I kept the value of voltage as 100 volt. Remember, for demo purpose, I just set the 60 volt. But when I conduct this experiment for these readings, that time voltage was 100 volt. Current, corresponding current is 0.375. And after that, I observe these much readings. And when I roughly calculate it, so it comes thermal conductivity as 0.281. It is not as a standard asbestos powder thermal conductivity is 0.15 to 0.18, but it is 0.281. So there are various number of possibilities due to which our reading is deviated from the exact readings. But this is justified because this is non-standard equipment, non-standard conditions. So it is possible that the exact value